Welcome to Brain Vision.
Hi everyone, this is the solution to problem 16 of Cotnell's Physics, chapter 24. So here, the problem is asking us for the angular frequency in terms of revolutions per second of the rotating set of mirrors that are shined upon by a given laser, which then reflects off of the surface or of one side of this mirror set, and then travels 35 kilometers, then travels back, impinges on the other opposite side, or this other side of the polygon, and then it shoots off to an observer. So something that the problem here doesn't tell you is that you're free to assume that this angle, this theta, is very, very small. So small, in fact, that you can assume the distance the light travels along this triangle is equal to 2 times L. So this is equal to the distance traveled by the light during this process. And so at the same time, we're going to rotate the system, and we want the rotation to be exactly in sync with when this light comes back and reflects off of the new side of the mirror system. And so how much time, we have to find how much time it takes for light to travel this distance to L, and then that's going to be the same time it takes for this 8-sided object to be this octagon to rotate by 1/8 of 360 degrees. So let's do that. So the distance traveled, well, we know that the speed of light is a speed, so it's distance over time. And so the time for light to travel this distance is just going to be d over c. So this is 2 times L divided by c. And so this time is going to be equal to 2L over c is equal to 1/8 of the time of the revolution. And so we want to know what that is, what this period is. And so we rearrange this equation here for t, and so we get 16L divided by c is equal to the period. But this is a period, and we want a frequency. So we want how many revolutions per second does this octagon do. And so this is the period. So this tells us that this is equivalent. This is the time it takes for 1 revolution to occur. And so if you want to know how many revolutions occur per second, then we want to find the frequency. But the frequency f is given by 1 over t. And so we just flip this equation around, and we get this is c over 16L. And we get that this is equal to 540 revolutions per second.